Lesson 7.7, Operations on Functions. This lesson will deal mainly with our new notation for doing things we've done before. The function f plus g of x represents the request to take f of x, the function f of x, and add it to the function g of x. So if we took f of x, 3x squared plus 7x, and added it to g of x, which is 2x squared minus x minus 1, we see that we have an expression that we've handled in the past. And in this situation, we would combine like terms. So we have 3x squared plus 2x squared is 5x squared. 7x minus x is a positive 6x, and then minus 1. And we've done that before, but we haven't done it starting with the notation that it was given. So in B, when it says f minus g of x, it's asking us to take f of x and subtract g of x. Now, unlike addition, subtraction is not the same in both directions, so it's not commutative. So we have to be careful about the order in which we do this. So this does indeed say f of x minus g of x in that order. Therefore, we would have 3x squared plus 7x minus the function, okay, so I have to have parentheses, 2x squared minus x minus 1. Now it's important because they're subtracting the function, so we have to distribute the negative. It wants the opposite of the function. That would give us 3x squared plus 7x minus 2x squared plus x plus 1. And then from there we will combine like terms. So now it is 3x squared minus 2x squared, so 1x squared. 7x plus x, so 8x plus 1. So again, things we've done in the past, but it's the new notation that we're looking for and trying to get comfortable with. Now I have a bad sign here, but this basically means times. And this tells us that they wanted us to take f of x times g of x. So we have 3x squared minus 2x plus 1 in parentheses times x minus 4 in parentheses. So this is a question of distribution. So if we take 3x squared times x, we have 3x to the third minus 2x times x is 2x squared plus x. And we distribute the negative 4. And we get negative 12x squared plus 8x minus 4. Combine like terms, and there is no x cubed, so 3x cubed. Negative 2x squared minus 12x squared is negative 14x squared. X plus 8x is 9x minus 4. The next one, and there's something missing here, I apologize for that, but this is f over g of x. And that's telling us to take f of x and divide it by g of x. So that means we have 3x squared minus 2x plus 1 over x minus 4. Now this is good enough for now. We have one rule that goes along with this, and that says that x cannot equal 4. If it did, we'd have 4 minus 4 in the denominator, and if you divide by, and then that's 0, and if you divide by 0, it's undefined. Now we're going to take a jump here. We're going to go to, out of order, we're going to go to this question. And this question asks us to find a composite function. And the composite function is going to use x equal to negative 2. So let's go through what this means. F composite, I want x to be negative 2. And order matters with composites, so pay attention. F composite g of negative 2 is the same as f of g of negative 2. In other words, we take the x value and put it into the g function first, and then what we're going to do is we're going to take the result of that and plug it into the f function. So this is equal to f of, now g of negative 2. G of negative 2 means we'll take 2 times negative 2 minus 1. That's negative 4 minus 1, in other words, negative 5. So g of negative 2 is a negative 5. If we plug in negative 5 into the f function, we get 3 times negative 5 squared times, minus a negative 5 plus 4. That gives us 3 times 25 plus 5 plus 4, which gives us 75 plus 5 plus 4, which is 84. Okay, now let's try the other direction. G composite f of negative 2 is the same as, again, order matters, so g of f of negative 2. In other words, g of, well, f of negative 2. Okay, so 3 times 4 plus 2 plus 4, 12 plus 2 plus 4, 18. Does that look right? Okay, so this is 18. If we plug in 18, or into g of x, we get 36 minus 1, or 35. So order matters. It depends. We have to read carefully to know what's going to use the negative 2 first, and that will change what gets plugged into the second function. So order matters. So here we are using two different functions. Each function uses up and changes the value the first time, and that new result gets plugged into the second function. So we are doing a composite. We're using two different functions to get our new number. I'll stop here, and this ends 7.7 Part A.